Looks easy, doesn't it? All you have to do is push yourself once, and you drift effortlessly through space. But there's just one slight problem. In space, there's nothing to stop you. And once you push off, momentum will keep you moving until you literally hit something. When you push something and get it moving, you give it momentum. Momentum is what gives an object or a fluid the tendency to keep moving. If you want to stop the object, you have to take that momentum away. That requires another push in the opposite direction. In space, there's often nothing to push against. So a jet-powered backpack called the Manned Maneuvering Unit, or MMU, was developed to help an astronaut move about. Steve Sebastian's job is to make sure the MMU controls momentum properly.
As the astronaut flies the MMU, he must keep several things in mind. His position in the orbiter bay and his distance from other objects in space. He flies the MMU by giving short impulses with commands with the hand controllers. He has to remember that once he starts moving, that he has to stop. So as he gives a command, he counts 1001, 1002. And he remembers that as he is translating or rotating, that he has to stop. In order to stop, he must give an opposite command. So, as he approaches a satellite or the shuttle, he gives an opposite command, 1001, 1002. He also remembers that as he approaches the satellite, that if he hits the satellite very fast, that he and the satellite may go tumbling off into space. So he doesn't want to do this. He approaches the satellite very, very carefully, slowly, approximately 0.2 to 0.6 feet per second. The MMU is just a small machine that produces short impulses to maneuver men in space.
Anything that moves has momentum. An impulse involves the push or the force that gets an object moving. But just as important to consider is what happens when an object is stopped and momentum is taken away. Again, forces are involved, sometimes very powerful forces. The amount of momentum an object or a fluid has depends on two things: mass and how fast it's moving, or velocity. If an object is moving extremely fast, like a bullet, it has tremendous momentum, even though the mass is very small. On the other hand, the captain of this ferry controls a very large mass moving slowly. It still has tremendous momentum, which will try to keep the boat moving right through the dock if he's not careful. A large mass moving slowly or a small mass moving quickly will have a lot of momentum. Momentum is important to measure because if you get hit by a moving object with a lot of momentum, you'll feel a lot of force. Force comes from the muscles of the attacker. Force acts over a period of time. In this case, a very short period of time. That's an impulse. The head of the opponent is moved by the force, and the force increases the head's momentum. The decreasing momentum of the head is then turned back into another impulse that moves the ropes. See if you can see the same principle happening with these billiard balls. Mass and velocity are all that momentum depends on, so it doesn't matter whether you move an object or a fluid. The effect is still the same. Trying to stop a mass of moving fluid creates an impulse that can sometimes be put to work moving turbines. In rotating systems, the amount of momentum still depends on how massive an object is and how fast it spins. You just measure it differently. Moment of inertia acts like mass, and the speed is an angular speed or angular rate. Sometimes momentum shows up in unexpected places, like in your furnace, for example.
This is the innovative Lennox pulse furnace. What we're going to look at is how this unit operates with no moving parts. Now, it does have the standard gas valve and temperature sensor controls, the air inlet and exhaust, but what we're concerned with is the actual heat exchanger section, the heart of this system. Let's look at the cutaway version over here. What occurs on this system is our gas comes in and our air comes in and is mixed in a very small portion down in the bottom. We have a regular spark plug which does the first ignition. That creates a small explosion. Now as that explosion happens, it travels up. So now we've got our impulse which has gone up and goes out eventually through the tailpipe section. So we've got our impulse, we've got the momentum now of that gas traveling, and then it comes back, which compresses and pushes down and actually causes the second explosion. This actually happens 60 times per second. If you look on a UL tag, it'll say 60 cycles. This is how they come up with the 60 explosions per second. So we've got our impulse, our momentum, and then our impulse again. This system, this heat exchanger, in the center of the furnace is what's actually doing the heating of the home, again, with no moving parts. Once it's started, it's self-propelling. Why don't we take a listen right now and actually hear what it sounds like.
Whether an impulse becomes momentum or momentum is turned back into an impulse, there's one thing that never changes: the amount of momentum. In other words, the amount of momentum you end up with will always be the same as the amount of momentum you started out with. Take a gun, for example. This is an isolated system. There are no outside forces. Before the shot is fired, the amount of momentum is zero. The bullet gains tremendous momentum as it leaves the barrel at high speed. The gun recoils in the opposite direction, but because the gun has a much larger mass than the bullet, it moves more slowly. These motions are in opposite directions. They cancel each other out, and the total is still zero. Momentum. Anything that moves has it. It takes an impulse to create it, and when momentum is taken away, an impulse is given back.
In the future, momentum is going to play a very big role in our lives as we start to work and live in space. And so you have to understand that an impulse is going to give you momentum and get you going, but another impulse is going to take that momentum away and make you stop. And if you don't understand that fundamental principle between impulses and momentum and motion, you're going to have a very hard time getting around. Now, how do you work this thing?